So this is going to be, it's a mock interview. It's going to be, so we're doing an hour long, okay? And the format's going to be, we'll just get
Yep.
right into it. And then and you usually get about, in an hour long interview, you'll usually get about 45 to 50 minutes of actual time and about 10 to 50 minutes of like stuff at the end. So first introductions, questions, etc. We'll only be doing the 45 to 50 minutes implementation, and at the end will be feedback, notes, questions, etc. Okay, so any concerns about the format before we get started?
Makes sense.
Okay,
No, it's
great.
all good.
Okay.
Let's go.
All right, so I'll dictate the problem. Please feel free to ask me questions whenever you have them. So today's problem, we're going to do merging lists. Okay, we'll be merging two sorted lists. So I would like you to write me a function called merge list,
Mhm.
and you'll take in the heads of two linked lists,
Okay.
and then you'll return the head of a linked list, which is the head of a list that is all merged. Does that make sense?
Yeah. Do you need to define the linked list structure and all of that?
There it is.
Okay. Good. 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 Thank you. Okay. So yes, it's node one. It's node two, and I need to return a head, right?
Yes, the head of a linked list, which
A
is the
head of
merged
the
list of the two.
merge.
Yes.
Okay. Makes sense. Okay. What did I define it? What was I saying? Was not closed, right? Uh, Wait, let me. Oh, I didn't num them. Okay, let's see. List one, list two. Is it good? I think was not closed. Do you need to even define that it's a list node?
What do you mean?
Like that I specified saying that it's like what is it saying? List node is not access.
Yeah. So
Is
so
is it
so
saying
this
that because I don't return nothing?
this isn't Python syntax. For Python syntax, you put the type after the.
Oh, after sorry.
If you
That's why it's
prefer a different
sometimes like
language, we can
optional
switch
or something.
languages. It's not a
Okay.
problem.
No, I just I never really define like actual right classes in Python. I just do like Leetcode and stuff. So most of the time it's already defined. Yeah, my bad. Okay, so we have two lists, right?
Yep.
We have list one, for example. I don't know, 1, 0. They're sorted or they're not sorted.
The two input lists are sorted. Yeah.
Sorted. Okay, so we would have like 1, 2, 5, 8. What's the constraints? Can they be empty? Can we have like both of them empty, one of them empty?
They could both be empty. Yeah.
Okay, okay. Both of them can be empty. Okay, and for example, this one has like, can we have negative numbers?
Yeah, they can have any numbers.
Okay, okay, sounds good. So we would have like -5, um, let's say 0, and let's finish at 8. Okay, so we can have like two, I'm thinking about like two pointers at the head node of each linked list, and then we're gonna compare the values of the two. Uh, Whoever has the smaller value, we make it. Yeah, actually, we need the third list. Okay, third list. Yeah, so whoever has the smaller value, we put it as a head node. Create a new node, put it as a head node. Then here we go to the next one. Then we compare them again. Whoever is bigger, we create a new node and put him here. Then we go to the next one. So whoever has um, a linked list with smaller value, um, add it to the new linked list and uh, move to the next one. Okay, for example, here we go to the 8. 8 is bigger than 1. We add 1. Then we jump again to 2. 2 is bigger than 8. We add 2. 5 is bigger than 8, we add 5. Then we have 8 and 8. Oh yeah, I forgot to ask. We can have duplicates, right?
Yeah, you can have duplicates. Yeah.
Okay. So will the correct answer would be just 8, or would it be just like 8, 8? So like double,
It
or we
would
can
be
just
double.
like
It would have all the
disregard them?
elements of the original list. Yeah.
Double. Okay, yeah. So then, for example, here would be like, if it's less than or equal to, then we just add this one and then jump to the next one. This list is empty. And whenever our list is empty, one of the list is empty, we're just gonna end the rest of the list that is left. The list. Okay. Okay. If we have, so we have, for example, empty list, and we have one with a one node. We're gonna compare. Oh yeah, we gotta check if. Okay, yeah, and then we just add this one. Okay, okay, sounds good. Okay, so first we gotta define the first node. First we're gonna do like current one equal list one, and current two is equal to list two. So we're gonna do while both of them don't reach 0, or both of them, yeah, basically they're not null. Okay, so while we have current one and current two, we're gonna iterate. Okay, so here at the start of this, we have -5, and here we have 1 for this example. Okay, so now what are we doing? We're comparing which one is the bigger one. So we can't just do max function. We need to, yeah, I think we just compare them manually. Okay, so if current one dot val is more than current two dot val, so if this one is more than this, then we add, yeah, and we need to create what we're returning. So returning would be list node. Yeah, list node. Oh, yeah. Okay. And we also need a pointer for it. So just do this one. Res.next is equal to this. Okay. Oh yeah, and I need to make let me just make new list, and the result will be just the start of that list, and then in the end we're just gonna return res.next. Okay. 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 So here, if the first list has a value bigger than the second list, we append the value of the second list. So new list dot next is equal to into creating a node. And so we need to create a new node. I don't think so. Let's try like this. Yeah. Okay. Wait. Current dot val. Yeah. Then current dot two is equal to current two dot next. Then elif our value is less than current two dot val. So if this thing is less than, or I think equal. Oh, if they're both equal, we can just move 2 pointers. Yeah. Okay. And okay. So yeah, new dot list would be the current one, and then if both of the values are equal, then we just add both of them. Yeah, so new list dot next is gonna equal to per one. Then oh, I never iterate. Yeah, okay. And new list equals new list dot next. You're gonna move the pointer. Yeah. Okay. Yeah, then I'm gonna move this, and then I just need to do this again if they have the same value. Yeah, actually, I think we need to create new nodes. Just create list node with the value of run2.val, right? Yeah, and then we switch the pointer, and here it would be current1.val. Okay. Okay. And here would be new doors. Yeah. Then we switch to next one, to this one, and then okay, makes sense. Okay. Now what else do we need? We iterate through all of them. Just removing. Oh, here I didn't move the pointers. Yeah. Here we need to move current1 equals current1.next, and current2 is equal to current2.next. Okay. So you're moving the pointers if they're both equal, and we take in the minimum one, whatever it is, move the pointer of the minimum one, and then do it again. Okay. Now, what happens when one of them gets to null? So, when one of them gets to null, we need to check if we have any lists end that are not empty. And we can do if this loop ended, so it means either current1 or current2 dot. So either we reach this, like null value, or this one. We can do, if we still have current1 pointer, then we still have current1 list. We're just gonna do new list dot next equals to current1. Yeah. Yeah. Elif, if we have current2, then new list dot next is equal to current2. Okay. Yeah. And then in the end, this is pointing to the dummy node, and the first value we put is actual next one. So first dot next. Yeah. Do you think that this looks good? Do you have any questions?
No, it looks good to me. Maybe a couple of questions just to kind of start the
Yeah.
thinking on this one.
Mhm.
In this case, I
Yeah.
guess you've assumed that it's sorting in increasing order. What if it was sorted in decreasing
Yeah.
order? What would have to change?
Ooh, yeah. So we would have to, for example, we would have, let's say, 10, 8, 5, and we would have 4, 3, 1, right? So here I would say we would just, instead of getting the minimum, oh yeah, wait. So the first element should be this one, then this, then this. Okay. Yeah, so instead of here, then going to the next one. So I guess we would define some dummy node like new list.next is equal to none. Then when instead of getting the smaller value, we would get the bigger value. So for example, in this thing, we would get 10,
Mm-hmm.
but we would need to insert it. Let me think for a second.
Right. So just to clarify,
For
so
example,
we're on
the
the same
value.
page here, right? So
Yeah, yeah.
we have the two input
So
list, which
you
you
would
wrote.
want 1, 3, 4, 5, 8, 10, right? So we would still have it in increasing order,
Yeah, you would
or
still return an increasing order, but to be giving a decreasing order. What would have to change about your algorithm to accommodate that list? To
yeah,
accommodate the new list? Yeah. Okay. Good.
yeah. So for example, we created a dummy node, this dummy node, and split into none. So here, we would need to put, for example, 10, right? So we just go to the last one, and I guess we can try to like reverse the list, but I think it won't be as optimal. So I think we just put it, for example, that we would store, let's say temporary is gonna equal to new list.next. So we're storing this one. Then we're doing new list.next is equal to the higher one. So instead of this, we would do the higher one, that is current one.val. Then after we put this, we need to connect this one to the temporary one we had. So you would have new list.next. I think we can do .next is equal to the temporary one. Okay, so for this one it works. Let's see if we had the smaller one. So yeah, so all of this. Oh yeah, and we need to move the pointer. So so you would move current one equal current one.next, and yeah, I think we don't need to move we'd have dummy and none like this. Yeah, I think here is good. Yeah, so here instead of this we would do time like this, but 2. Okay, and if both of them were the same, we would need to basically input 2 nodes. So for example, here we would have like I don't know, 8, 8, right? So we would input 10, loop again, and we would have this one and this one. So we have same values, and we would need to input 8 pointed to 8, and then again to 10. Okay, how we have done that? Let's see. So, oh yeah, and here it would be current to, yeah. So here we would still store our next value. Then we would create new list.next. So you would create this one. We didn't connect it yet. Then we're gonna connect it to this one, to the 10. And I guess we can just like repeat it basically.
Okay.
Yeah, I think we can just repeat the same algorithm. So we just store this one again, and we create a new value with same values. We would have like 8 and 8, but they're not connected yet.
Yeah.
And then we just again connect them, and we need to switch the pointers. I think so, right? Yeah. So we need to switch current one equals current one.next, and we would have current two is equal current two.next. I think something like that. Let me double check. This three. Yeah. I think this one, yeah. And then in the end, in the end, 5, 1. So for example, we get to 5 or whatever, right? No, we get to 5. Then we go to the next one, and for example, we would have like 5, 5. We'd move here. We add 2 of these 5s. Then
Yeah.
we move our pointers, and this pointer is null, right? Is null. Then we just have the second list. So yeah, so I guess it should still work. We just, oh no, wait, no, it won't work. We need to do again. So we would have like basically like let's just say 5, and we need to put this 1 here. So we would again probably do this thing. We would store our 5 and the temporary variable. Then we would move our next pointer from dummy to the one that we created, basically, to this one. And after we created, we just link it to our 5. Yeah. Okay. Yeah. And then in the end, we just still return res.next, our dummy node.next. Yeah. Think it should work.
Okay.
Is there any? What do you think?
No, I think that's fine for now. Let's move on to the next one. Um,
Yeah.
actually,
Okay.
before we move on, let's talk about the time and space complexity of this implementation.
Oh yeah, yeah, yeah. So here we need to traverse both lists either way. So you would say one list has m elements and the other has n elements. You would just need to traverse n plus n, right? Yeah. And then the space complexity, what are we storing here? We're creating a new node, a new list with all of the nodes, right? Yeah. But actually, we're just storing the pointers. We're just storing one value at a time. So, uh, creating 2 list nodes. Is it, I don't know, all of one? Is it all of one? Because we're not storing the whole new list, right? We're just storing the pointers. Or is it still m plus n?
If we also include the return value, let's say put it that way. If you include the return value,
Oh, yeah.
what would it be?
Yeah, it will be m plus n then.
Okay,
M plus
if you
n.
don't include the return value, what would it be?
Uh, I think we just all of one. Because we're
Okay.
just storing like one value at a time, right?
Okay. Okay. Let's move on from that then.
Yeah.
Let's
Yeah.
we'll move to a second problem. It's a very similar problem, but I recommend making a new function for this, so don't modify the previous one. Um, in this time,
Oh,
we're
okay,
going to
okay,
be
okay.
yeah. So in this time, we're going to be doing the same thing. We're going to be merging sorted linked lists, but instead of 2 linked lists, we'll have k linked lists. So your input will be a
Ooh,
list
okay.
of heads of linked lists.
Ahead of linked list. Okay. We just have one list with the list node, right? Okay. Okay.
So the input will be a list of heads.
Sorry. Wait. So this is then. Yeah. So this is an array of heads, right?
Yes, it'll be an array of heads.
Okay. Okay. Just like this.
You can just submit the type for now.
Yeah. Yeah. Okay. So you have an array of heads, right? Of the linked list. And do you know how many linked lists is there? Like k, right? We have it,
Yes.
right? Okay. 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 For example, we have, let's say, is equals to 3, and uh, we just have the heads. We would have like 1, 2, 3, and we have another array, like, I don't know, 2 and 4. Then the third array, 4 and 7. Okay. Okay. Can we have k0? Right.
You can have k0.
Okay. If we have k0, then we just return none. Okay. So you have, I guess we have k1. We can just return that we got. So like list 1 to 0. Okay. Now we have 2 and more. So I guess it's kind of like iteration. We just gotta again use our algorithm here that we did before. But yeah, let's think. So if you would just do it like iteratively, merge this and this, then the end result you just merge this and this one, right? But how much would it take? We would do m plus n and then another one, and we would need to store the values. I think. Because then the naive approach, let's try to, I don't know, do it. Just merge first two lists, you merge them, you get a new list, then you merge the list you got and the next one.
Yeah.
So I think I remember doing this problem, but I don't remember the trick. Let me think. A link list. A link list. I guess instead of just merging one by one, we would have like we would have like 4, and then we have, I don't know, like 5, 8. We can just merge these two, get the our current one, and then merge these two. Yeah, so let's try to do it. Okay. So what do we need to get the first two values? We have an array. So an array, we basically just have this. Okay. So let me think, how can we implement it? We do while loop, I think so. Okay, let's try while loop. So while our is to define some index. So if I equal 0, so what do we want them to take? Have this merge list function basically, right? What do we want? We want to put to merge list the list. I don't know why I defined it list 1. We just do this list at I and list at I plus 1. We want the first two, but we can get out of bounds if we can do that. So we need to check while I plus 1 is in the range, right? So if it is less than length of our list. Okay. Okay, so we got this one, we got these two, then we're gonna give it, it's gonna return a head. We're gonna just, let's say, new list 1.
Okay.
Then we want to do the same for new list 2. But, okay, here we need some conditions. So here we guarantee that we have at least I plus 1. And here we can have these, we have the third one, we can have the fourth one, or whatever. So, new list 1. Oh, wait. Can we remember the name? Okay. Oh, wait, I think we don't need to do it even at the same time. I think we just create again a dummy node. Okay. Dummy is equal to dummy.next is gonna be equal to this. How do we get the end value? Ooh, yeah, so this one should be this.1. Then we move 1 second.
So are we just, so just to clarify here, we're trying to do a brute force solution where we use our previous merge list implementation to merge all the pairs of lists
two
in the
lists.
array. Yes.
Yeah, I think so.
Okay.
Let me think if there is more optimal one.
There's definitely more optimal one, but we should maybe draft this one up first before we move on, so we at least have an answer, right? So the way I
Okay.
was
Oh yeah, true. Okay.
right. So the way I think with this is that we don't really iterate two at a time. We can just iterate one at a time, right? So why don't we get a pointer to the first linked list, and then we iterate
Out of the first one
through
first.
all of the list from the second onwards, and we guarantee there's at least two, right? Because these two conditions are checked. Right. So let's get a pointer
Then
to the first list.
yeah. So current one is equal to list at 0.
Great. And this will be the head of the
Right.
first list, right? Yep.
Yeah.
Okay. And then let's rewrite the loop a bit. Let's just do a loop through the list starting from index 1. So starting from the second element.
Okay. For I in range of from 1 to the link of the list, and you're saying we just iterate
Just one by one.
By one.
Right. And
Okay.
we want to merge the current list
Okay.
with the current index list.
With the next one.
Right. And we update.
Oh yeah, with the current one. Yeah. Yeah. So we would have current one we have. We're gonna merge it with this one. Can we just call we're saying our old function, it's like slow or
Yeah.
not efficient?
What's that?
You're saying our we can't just do this one, right?
You can do
Current
that.
and whatever. Is this what you were saying?
Yeah, this would be a brute force implementation, right? Was this what you were trying to do?
Yeah. Current one, then this. Yeah, I was trying to merge it like by pairs. But I don't know, how do we... You're merging these two? Is there a difference if you're merging it by pairs or if you're just merging it one by one? I think there it is, right?
Yeah, there's definitely a difference, but do you know what the difference is?
Yeah. I think we're merging one by one, then we always need to store our old value. But we just merge two of those. Oh wait, we can just merge these two, then we just merge these two. And then we can just call merge on all of them, right?
You could, yep.
Like on the both one that we had. Well, if we would have more, for example, the first one, like whatever. What would we do? Guess we can just minimize them, merge them by 2, and merge them in pairs.
Yep, you could. I mean,
Let's see, how would I
so I wanna just
implement
clarify
it?
that if you you can merge them by pairs. You can iterate to you can iterate two at a time to merge them
Yeah.
by pairs.
Yeah.
But and so in that case, what would be the is that going to be more efficient?
I think yeah, because we won't be storing the extra node, right? Because if you merge this one, we're gonna have another head. Then if you merge this one, okay, let me just think. So we're merging this one, we have like 1, 2, I don't know, 2, 3, 4, right? Then we're merging with this one. Then we're gonna iterate from the list 1, list 2, returning this one. Okay, what would happen if you had it in pairs? I'm just doing the same amount of merge, because this one takes 1 merge, this one takes 1 merge, and then in the end, we have third merge. And if you do it just like this, like 1 merge, 2 merge, and the third merge. So I guess the time complexity is the same, but the base, having two head pointers,
We can. I
then we're
mean,
just
look, we can do
merging
it. We can
them.
do it two at a time too. Just so we're not stuck on this, right? So let's just do it like
Yeah,
this then. So don't worry what magic is. Just assume that we get A and B. So it's two. It's pairwise, right?
yeah,
So what would you do then?
yeah. We just call the merge list on A and B.
Okay.
You're saying A and B is like this one, right? The first one and the
Yeah,
second
yeah.
one,
So
right?
so the A would be the pointer to the first one, and the B would be the pointer to the second one.
Yeah, yeah. Then we need to save that one. So we obviously can like whatever, like get the next one. I just say I don't know. Oh, it's iterating, yeah. Okay. And we would need to store this head in some temporary. So let's just say temp1. Then we're gonna store the next one, and let me see. Merge this one. Did you merge the next two? Yeah. Okay, look. Just say, do you connect it to the dummy node? So just say temp1 is equal to the dummy node, right? Then temp1.next. Is it temp1.next? We connecting to this one, but oh no. So we just store the head. Then we would have like temp2 merge list. So to merge these two, we would need to wait for next iteration, right?
Sorry, to merge which two?
The next pair. You would just like wait for the next for loop, right?
Yeah.
For the next
Yeah.
iteration.
So A B in the first iteration will be these two, and then the next iteration would be these two.
Okay, yeah, I see. Okay. You need to always connect them. Just say, I don't know, temp1.next is equal to this, but these two. Oh yeah. Every time, then we need to merge our, I just say this is temp2, right? And then we need to call the merge on our current list and temp2. So, sorry, yeah. So this would be our temp2. Temp1 is nothing. We merge them and we put it into the, let me just say dummy.next, is that right? I think so, right? So we merge these two, yeah, dummy.next. We merge these two. Okay, then we went to the next loop. We have this in the dummy nodes merged. We're merging these two. We have these two here. Then we're merging the, oh, we didn't update the temp one. Okay, yeah. So the temp one is need to again equal dummy.next, I guess. Yeah. Then we just again merge these and whatever we have here, we merge them too. Then we put it into the dummy.next. this one's merged, right? Okay, let's try, what if the B is empty? So it would be A and B. Okay, I think it still would work. Okay, wait. temp1.man next. And try one more. We would have like, I don't know, whatever. 8 and 9, right?
Okay.
We have all of this in our dummy.next, the head, temp1. Then we merge these two again. We store it in temp2. Then we merge all of that we had before and these two. Oh. Okay. And then we just would return dummy.next. Will that work? Am I missing something?
Okay. There is. I mean, I guess a question. I mean, we can just go to analysis first. What's the time and space of this function of this implementation then?
Yeah. Yeah, so time one, it would be how much? Okay, so all of the lists have different sizes, right?
Yeah, they can have different sizes.
Okay, so we can
But you
have
can assume that for this exercise, you can assume that the longest one is
whatever.
length n.
Yeah, let's just say n. So this one would take like 2n, this one would take 2n, this one would take 2n. So would it be, it would be, how many times we calling this function? For every 2. So I guess it would be n times what? Times the number of pairs that we have. So an, but basically, but we're just iterating. No, wait, no, we're not iterating through the list one time. We can iterate multiple times. Ooh, how much would it be? I'll just say the worst complexity. We just have like 1, 1, 1, 1, 1, 1. To iterate through all of them, like, uh, one, two.
So what did we decide the complexity of merged list was? Right, we said it was n
Yeah,
plus
so
n.
like
So basically
of
n plus
like
n.
two O of n, O of n.
Yeah, O of n. Yeah,
Yeah,
O of
O
n.
of n. Yeah. And then we're calling this loop. But the problem is like restoring the temp1, all of the previous one. And when we call it on the new pair, this pair is basically yeah, O of n. And this pair, we again reiterating through all of the old elements. Would it still be O of n?
We can come back to that, but let's
Or
just write that down for now.
yeah, I think this one is yeah. Okay.
And
The
but
space.
before we
What is the
get before we go
space
into
one?
space though, like where's the k?
Yeah. Oh, you know, K list. You have what, like, K times n?
Okay, let's talk about space.
Or no, wait. 1, 2, yeah, I guess it's K times n. Okay. And the space one, ooh, if this one grows really a lot, but we just reassign it to every element, right? So, we have the, I think it would still be all K of K times n.
Can you explain why?
Because we have, let's assume all of this list, yeah, they're the same space.
Okay.
And our temp1 grows. First we have n, then we have basically 2n, 3n, and the other two we merge in temp2. There are always 2n elements. So overall, I guess in the end, when we finish up in temp 1, we store all of the elements in this list. And overall, there's k times n elements because we have k arrays, and each array has n elements. Not a linked list.
Yeah. Okay, so what's the overall space?
K times n.
Okay.
Yeah, because this one isn't gonna grow a lot.
Yeah. Okay. I see. I think I see where you're coming from. Okay. That
Yeah.
brings us to time. So, for the next 10 minutes or
Okay.
so, let's talk
Yeah, I
about
think this one
what
I
happened here.
I
Yeah.
missed it. Yeah.
Uh,
I think maybe I had an idea of just minimize these two, but I don't know if it would work. Like, yeah,
okay. Yeah. I mean, we can talk about it. So, let's start from the top. I won't go through all the notes. I can see the notes after.
yeah,
But the first problem, we'll just kind of glaze through just really
yeah,
quickly. Not really much to say.
yeah,
There was something I wanted to say that was unnecessary, which was that you were allocating new nodes for every merge. That's not
yeah. So
necessary.
could I use the old one?
I mean, you didn't ask, but
Oh,
yes,
okay,
you could
okay.
have. But you should have asked.
Yeah,
Because
yeah,
this is why we're using extra
yeah.
space.
True,
If it was
true.
for this, it would be O1, but you are using this, so it's not O1 space,
Yeah,
right? Um,
yeah,
so that's a note there. Otherwise, it's fine. The follow up
yeah,
about the inputs being descending instead. The first thing you should have asked here, honestly,
yeah.
was just what's the requirement?
Mhm.
Like, do I need to make this time optimal? Do I need to make this like uh, like what am I optimizing for? And the reason you want to ask that is because if your interviewer just says, oh, I just want to see how you think, you should be going for the easier solution first, which is just reverse the linked list, right? There's no need to spend so much time on a more optimal solution than
But
that,
okay, yeah,
right? So yes, it is more
okay,
optimal, but I didn't really care about that.
yeah,
So it's always good to kind of check in on
okay,
that.
yeah,
Okay, so that's all about the first
yeah.
one. I mean, the second one's kind of where
So
the
also,
real problem is. Any question on the
yeah,
first one before we move on?
yeah, yeah.
Okay, let's move on then. Um, yeah, so obviously this is the real problem, right? The first one just a warm up. The main thing about the second problem here is
Yeah,
uh, you had a correct intuition. I mean, you said like you said you did the problem before. By the way, like in an interview setting, if you've
yeah.
done a problem before and you want to be honest, say that up front. Otherwise, don't say it at all. Right? Saying it afterwards is not doing any good.
I do to you because I. Yeah, yeah, yeah,
Yeah, but I'm not going to help you any more than a real interview. So, I mean, just like that's just for your note,
yeah.
right,
That's
for the
true.
future. Um,
Yeah,
right. So the main thing
yeah.
about this problem is that yeah, you had the correct intuition, but you didn't justify it correctly. You didn't understand why that was correct. So, what is correct? The correct solution in this context, the one that you were going for, was a bottom-up divide and conquer. Okay. So, I'll just continue down here, right? So, the main thing here is that you actually had the intuition to merge lists pairwise. But the reason you described it incorrectly was because you didn't actually understand the benefit of doing them pairwise. And the reason you want to do them pairwise is you want to continuously do them pairwise, right? So let's say we had a list of one. Let's do this, okay? Like imagine these are heads, right? I won't write the arrows, but imagine these are all heads. So we have 5 heads, right? The first loop, we want to merge 1 and 2. Then we merge 1, 3, and 4, and then 5 just gets left out, right?
Yeah.
In the second one, we want to merge 1, 2, 3, 4, and then this will still be left out, right? And then in the third iteration, we want to merge 1, 2, 3, 4, 5. Okay, so what does that mean? This basically means that we will finish merging in the ceiling of log k. The number of iterations it takes is the ceiling of
Uh,
log k, right? And that's because we
okay.
continuously
Yeah,
pairwise merge them. So you can't just merge them once pairwise
yeah,
and then just do them iteratively like this. If you do it like this is the same complexity as if you did it the original way I proposed, which is just do them one by one,
yeah. That's true. Yeah,
right? It's the same thing. So
yeah. I
you
just
had
got lost on how to store the new pairs we got. Yeah, that's where I got lost.
right. So and like one thing to keep in mind is that if you're not allocating new list nodes, I mean in this case you are, but if you weren't allocating new list nodes, it doesn't matter how you store them, because you're just rearranging pointers in existing memory. You aren't actually making new list nodes.
Oh, so
So
you're just changing the actual list inside of it, right?
yeah, you can change that. Yeah, I mean, I didn't say you can't. I mean, you should ask, but I didn't say you can't. And these
Okay.
pointer manipulation exercises,
Okay.
like it's meant that you're supposed to just move pointers around. You're not supposed to allocate new ones, right?
Okay.
So this is the solution you were actually trying to implement. Now, obviously, I can tell, but I can't do it for you. So the hint given was
Yeah.
okay. If you aren't able to justify this, you just get stuck. Like which is what happened here. Okay, what you wrote is the same as what I proposed. So in these situations, you should just be making the brute force one, right? If you can't figure it out, just write the brute force first, and
Mhm.
then see what you can optimize. Okay. Now let's talk about
Okay.
another one. So another one, which is I would say is easier to reason because in this case you're trying too hard to think about the end situation. Instead, you should be thinking about how to reduce the problem space in the current situation, right? So, for example, let's say I'm trying to let's try to implement this, right? What you should be doing is, for example, now this isn't real code; it's just pseudocode, right? But you would be doing something like, okay, merge k link.
Yeah.
So call it recursively with the first half of the list. So 0 k divided by 2, right? Like so, right? So do it separately, right? Pointer 1, call it cur1, right? Cur1, cur2, right? Merge them both recursively, right? And obviously base case, right? Base case k equals 0 or 1, right? Merge them recursively. In this way, you also accomplish the same thing, right? So in this case, we're starting from iteration 3. We start
Yeah.
with all the lists. We break it into 2, which would be 1, 2, 3. Let me start like this,
Yeah.
right? This is what a recursive call will look like, right?
Yeah.
And we break it down further, kind
Yeah.
of like this, right? And then so
Yeah.
once you get k equals 2,
Yeah.
right? If k equals 2, merge list AB, right? Right? And otherwise you call it recursively until it is k equals 2, right? So if you do get stuck on these kind of bottom up approaches where you're trying to think about how the individual elements in the list play out in this divide and conquer algorithm, you can try thinking about it recursively as well. Because that way you think about how, like, what do I need to currently do
Okay.
with my current list? How do I divide the current list to conquer it? Right? So this is just a tip for you, just going forward.
Mhm. Yeah.
Does that make sense?
Yeah.
Okay, great.
Yeah.
And the last thing I'll say,
Totally.
which is not what you thought of, but a different solution, which I personally think is probably a bit easier, is using a priority queue instead.
Mhm.
Have you used priority queues in Python, like heap queue?
Yeah. 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 Yeah.
Okay, yeah.
Yeah.
So you should know
Yeah.
that solution.
KQ. Yeah.
Yeah. So these kind of solutions, I mean, it's very personal, right? You might prefer divide and conquer. That might be easier for you to reason. Some people find the priority
Yeah.
queue solution easier to reason. So don't be married to a single solution, right? Be like connect all these ideas in your head, figure out why is it that these
Okay.
all work, and then go from there.
Yeah.
Okay. So there's many
Okay.
different approaches,
Yeah.
and I
Makes
won't
sense.
focus on that. You can obviously study it in your own time. I won't waste time on that. But one more thing I will say as well is about the time and space complexity analysis. So the first one was correct. That one's fine. You did well on that. By the way, it's good that you used M and N for the two lists. That's usually something people miss. One thing you could also say, by the way, just to simplify in the future, I
Yeah.
think this is what you did is good, but you could also simplify and say, let N be the longer of the two lists, right? And then you could do O of 2N. So, it's the same thing. But
Yeah.
anyways, what you did was fine. Why that matters in your time complexity analysis for the second problem is that it's not like you're breaking an invariant, right? And the invariant is very simple. The invariant you're breaking is that in is no longer the length of the list. In was originally the length of the longest list. Okay, let's say we can make it simple. Let's say the all length in, right? The all length in. In is the length of the list on the first iteration, but guess what? Immediately on the next iteration, it's already 2 in. Do you see?
Yeah.
And then next is 3 in, and then 4 in,
Yeah.
and then 5 in. And then how big is it? It's k in at the
Yeah.
end, right? So if your list is on, if your
Yeah.
list is k in at the end, that means the average length was k over 2n, which is k in asymptotically. right? You can reason that in your head.
Yeah.
So that's k not enough. So it's actually
Yeah.
not k in, it's k times
Yeah.
n.
K times K. Yeah. Okay.
Right. So that's kind of the reason here.
Makes sense.
So
Yeah.
so you keep that in mind, right? In is the length of the list, but only at the beginning. But that changed, right? Because your
Yeah.
inputs over here is changed. Now it's two
Yeah.
and three and four, and it's kn now. So you gotta keep that's tricky.
Yeah. Yeah.
So, but you gotta keep in mind, like if you're gonna do an iterative
Yeah.
solution like this, rebuild a list, this is gonna just be marked wrong, right? Like I mean, like this is just wrong. So, like you have to be very careful about that, right?
Okay.
Okay.
Yeah.
Couple. I mean, we're a bit over time, but I mean, if you have any questions, I'm happy to answer them right now. It could be either about the problem or in general about
No,
the
I think
performance today.
it's yeah. The first one it was like easy, just merge list. The second one, it's like I understood the pairs one, but I just like I couldn't like understand how could I like carry over to the
Uh huh.
next like iteration, to merge them. And with the yeah, sure, like you said, I should have thought about it with the recursion. Because like yeah, I could have just made like two pointers and then like return it and merge them together.
You
But with the
divide and
I
conquer, right?
forgot
Yeah.
in the yeah, divided. That's what I was thinking. Like, I was like, okay, I can just like minimize them. Like instead of these two, I would just have one list. Then these two, then I just have one list. But how I couldn't understand like how could I like not memorize them, but carry for every iteration because that's why I tried to dummy next, and I was like, bro, I'm just doing the brute force. I was like, what am I doing?
Yeah. No, I feel. I mean,
Yeah,
like that's honest. I mean, there's two things, right? First of all, is like, yeah, you shouldn't be forgetting that if you've done it before, especially, right? So maybe go back, figure out, like, do it in more
yeah,
detail, do a little more analysis on it, be a bit more careful about it, and
yeah.
also obviously for this problem, you should try both the divide and conquer as well as the priority queue solutions. I think they're both good to know. And then also just in terms of strategy, right? If you're not able to reason the optimal solution, and you know there's time pressure, you should just be going to write the brute force one just immediately, right? I'm assuming you thought of the brute force one pretty soon, right? So
Yeah, yeah, just
right,
like iterating at the next one.
yeah, just iterate and build a list, right? So if you can't think of optimal one, what you can do is and to be honest, if you're not confident you can think of it, you should just be writing the brute force one, buy yourself some time while writing it, and then think about the other one,
Okay.
right? So that way worst case
Hmm.
you just wasted some time writing the brute force, but at least you have
Yeah,
something down on the page and it doesn't look that bad.
yeah, makes sense. Yeah. What would be the time complexity for this Payers one? Would be the same?
No, it would be so that would really depend on how it's implemented. This is not so we didn't get there, so I can't comment on it. But the reason it would depend is because
Mhm.
some people still wouldn't use the correct. Some people don't merge it the right way because you can divide and conquer, but
Mhm.
instead of doing it this way, you could do it like this way, right? And this is the same as
Oh,
what you did, right? So if you do it this way, this is the same
yeah,
complexity.
yeah,
In fact, it's actually well, it's not actually worse, but it's
yeah.
about the same. If you do this way, then it's better. I think this way would be in log K.
I'm okay. Okay.
So
Would the space be the same?
no, the
I
space.
think space will be the
The
same,
space
right?
is so the space will also depend, but the space would be log K ultimately.
Okay. Okay.
Yeah, it'd be log K if you didn't. So if you didn't allocate nodes, right? If you allocate nodes, obviously bets are off the table. If you
Yeah.
didn't allocate nodes, you just move pointers. The
Yeah,
entire
yeah.
logic is O1 space, but because it's recursive, it's log K because
Hmm.
log K is the depth of your stack,
Okay.
right? Because you have log K depth
Yeah.
over here.
Yeah. Makes sense. Yeah. Okay. Yep.
Great. Okay. Well, that's all then. Thanks for your time. Thanks for participating.
Makes sense. Yeah. Thank you a lot. Thank you a lot for helping. Yeah. Are you doing the resume reviews today?
Yeah, I'm doing this for a while now. Yep. So you can come
Okay.
back
Okay.
at 2 p.m. in 2 hours or so. And we'll do that.
Okay. Okay. Yeah. Thank you a lot again. See you.
Okay. Good. Take care.